Welcome back, chemistry fans. Today, we're going to cover the last topic dealing with periodicity, the trends that are on the periodic table. Fancy word, and normally it involves quite a few trends that we need to be able to understand. However, I had an epiphany this morning, and what that means is that we're asking you to work with trends that tend to only be relative to you after we have understood how atoms bond together. We haven't got that, so we're only working with the atomic structure. So that's what we're going to start with this morning. Let me share my screen and we'll get jumping right into it. Okay, so notice on this image, this first image here, you see that there are numerous trends that are available to us to discuss on the periodic table. There's ionization energy, electronegativity, there's electropositivity, there's character. We're only going to deal with one of those because we haven't talked about bonding yet. We're going to talk about atomic radius, these pink ones. And what you will notice is bottom left corner is where we have our largest element. If you understand that, you've got the trend memorized already. Look at this, and that reiterates that exact same trend, is that as you go through the periodic table, there tends to be a predictable pattern. It raises up on one side of the periodic table, and then it starts to get smaller as it moves across the period. Then it raises up, and it starts to get smaller as we go across the periodic table. And so that trend can be predicted and explained. Let's understand what an atomic radius is. An atomic radius is the distance from the center, the nucleus of an atom, out to its valence electrons. Now, the reality is we actually can't measure one atom. So what they'll do is they will take the total distance between two nuclei, and then they will divide that in half, and you end up with what is the atomic radius. Now, what that translates to on your periodic table is a nice little trend. You will notice from these images, the size of the left of the periodic table tends to be larger than the elements over on the right side. So as we move across the periodic table, it gets smaller. As we go down the periodic table, it tends to get bigger. And so if we were to rewrite that, we would say that the biggest elements are in the bottom left corner. Of course, there are exceptions. And you notice I've shrunken this periodic table just to the primary elements on the left and the right. We've taken out all the transition elements. There's some different trends that occur in there, but we want to talk about predictability. And we will note that francium in the left corner is the element of largest size. Now, why is this? So we need to understand the big trend is being governed by increasing energy levels. As you go down the periodic table, you are adding new rings. Every time we add one of these concentric circles, we increase the diameter from the nucleus out to the valence electrons, and so it gets bigger. So as you go down the periodic table, you have 7 different energy levels, and that is, and that is what we are trying to see here. So let me flip over to a periodic table so that you can notice that. So here we have 7 energy levels. Here's 1 at the top left corner. Here is 7 down at the bottom. That means that francium has 7 rings around it. That means that hydrogen only has 1 ring around it. So that makes it bigger. Now, as far as why the trend gets smaller as you go across, that's counterintuitive. Why in the world does it get smaller as you go across? You would think that it would increase because you're adding more electrons. Well, the reality is it's just the opposite. We are on the same number of energy levels. In this image, we have 6 energy levels, 5, 4, 3, 2, 1. So we are not changing the number of energy levels as you go across. It has the same number of rings, but we instead are putting more protons into it. And then there is the attractive force that occurs because the number of protons increases the nucleus size, and that shortens the distance. So what you would need to understand is that this distance is further apart than this distance whenever the nucleus gets bigger. And as if I add more more protons, it continues to increase the size of the nucleus, but the size of the electron's energy level does not change. So then there's a magnetic attraction that pulls a negatively charged electron closer to a positively charged neutron. I'm sorry, a proton, which causes it to attract and decrease in size, giving us the overall trend that we notice here. Okay, this is everything that I wish to share with you today about atomic radius. Thank you very much. Let's go take a test next time. Bye.